Welcome back, everyone. Good morning. Thank you for joining us. I'm Steve.
And I'm Scott.
We're in Apple Valley, People's Republic of California.
Yep, and it's a beautiful, I guess you'd call this an Indian summer, right?
Yeah, it's nice.
Beautiful weather. And we're talking rogue today. We like rogue. I can relate.
Yeah, and this is so interesting because we talk about how the Savior created the heavens, and it was not a flick of the finger, and then boom, there it was. We're watching this unfold, and that's how it happens. It went over time, and we're watching this right here. So listen to this. A runaway rogue planet is gorging on space dust at a rate of 6 billion tons per second. 6 billion tons per second. The event marks the fastest planetary growth ever observed, hinting that some planets form more like stars. These observations were reported in the Astrophysical Journal Letters on October 2nd, 2025. Would you like to know more?
I want to point out something too, because these stories that you come up with, most of these stories are within a few days, if not a few weeks, of the information that we're putting out, and we're just passing on the information. But you're right on top of these articles. So I just wanted to point that out. I meant to mention that a while back, but I just wanted to give you a plug on that. So
thank you, Scott.
Yeah, I know. Don't let it go to your head. Astronomers have spotted a massive growth spurt taking place in a rare type of world known as a rogue planet. Unlike the familiar planets that circle stars, these cosmic wanderers drift freely through space, and using the European Southern Observatory's very large telescope, which we talked about before, ESO VLT, researchers discovered that one such planet is rapidly consuming gas and dust from its surroundings, about 6 billion tons every second, which I can't even fathom that. This is the fastest growth ever observed in a rogue planet or any planet, offering new clues about how these isolated worlds form and evolve. So
you got to think that eventually this rogue is going to be caught in some star's gravity pull, and then eventually start rotating around the star. It just needs to get close to one. You got to think that.
Yeah, and what's its choking point? What if it tries to get 7 billion tons of dust and it chokes?
You can't. If there's no dust at all, you can't get it. So maybe when the dust runs out.
Yeah.
All right. Quote: people may think of planets as quiet and stable worlds, but with this discovery, we see that planetary mass objects freely floating in space can be exciting places, says Victor Almendros Abad, an astronomer at the Astronomical Observatory of Palermo, National Institute for Astrophysics, Italy, and lead author of the new study.
The object, officially called CHA, C-H-A, 1107-7626, lies about 620 light years from Earth in the constellation Chamaeleon, and it has a mass between 5 and 10 times that of Jupiter, which is pretty big.
Wow, yeah,
it is still planet. Yeah, Jupiter's pretty good size, so 5 to 10 times bigger. It is still in the process of forming, surrounded by a swirling disk of gas and dust that continues to fall onto the young planet in a process known as accretion or accretion. Almendros Abad and his colleagues found that this feeding process is far from steady, showing dramatic bursts of activity. Okay.
By August 2025, the planet's accretion rate had surged to roughly 8 times what it had been only a few months earlier, reaching 6 billion tons per second. Quote, this is the strongest accretion episode ever recorded for a planetary mass object, says Almendros Abad. The finding was made using the X-shooter spectrograph on ESO's VLT in China's Atacama Desert. The researchers also incorporated data from the James Webb Space Telescope, operated by the U.S., European, and Canadian space agencies, and archival observations from the Symphony spectrograph on ESO's VLT.
Quote again, the origin of rogue planets remains an open question. Are they the lowest mass objects formed like stars or giant planets ejected from their birth systems? Asks co-author Alex Schultz. Schultz,
Yep.
an astronomer at the University of St. Andrews, United Kingdom. The findings indicate that at least some rogue planets may share a similar formation path to stars, since similar bursts of accretion have been spotted in young stars before. As co-author Belinda Damian, also an astronomer at the University of St. Andrews, explains, quote, "This study blurs the line between stars and planets and gives us a sneak peek into the earliest formation period of rogue planets."
By comparing the light emitted before and during the burst, astronomers gathered clues about the nature of the accretion process. Remarkably, magnetic activity appears to have played a role in driving the dramatic infall of mass. Well, I mean, if the core is made out of iron, yeah, I could see that. Something that has only been observed in stars before. This suggests that even low mass objects can possess strong magnetic fields capable of powering such accretion events. The team also found that the chemistry of the disk around the planet changed during the accretion episode, with water vapor being detected during it but not before. This phenomena had been spotted in stars but never in a planet of any kind.
Free-floating planets are difficult to detect as they are very faint, but ESO's upcoming extremely large telescope, which is going to take the place of the very large telescope, maybe? I don't know.
The mother of all telescopes.
Yeah. Operating under the world's darkest skies for astronomy could change that. Its powerful instruments, and giant main mirror will enable astronomers to uncover and study more of these lonely planets, helping them to better understand how star-like they are. As co-author and ESO astronomer Amelia Bayo puts it, quote, "The idea that a planetary object can behave like a star is awe-inspiring and invites us to wonder what worlds beyond our own could be like during their nascent stages." I don't know what that nascent stages means. Building stage, maybe? I don't know. It sounds like this thing is a pig, though.
Yes.
It's a pig. Yeah. It just devours everything in its path. So
yeah, it's pretty cool.
Crazy. Yeah.
All right, folks. Thanks for joining us. We'll catch you in the afternoon.
You heard it here. Talk to you later. Thank you.